Okay, we'll get going because time is rolling on and you're taking time out of your busy days to come and listen to us today, which I thank you very much for. Andrew, if you just want to move to the next slide, please. Okay, so here's today's agenda. My name's Gavin Morgan. I head up Industrial IoT business within CAD-IT. And joining me today and delivering the bulk of this webinar is Andrew Howarth, who is our Senior IoT Application Consultant. So I'm just going to give a very short introduction to CAD-IT for those people who are not familiar with who we are and what we do. And then I'll hand over to Andrew to give a live demonstration of our overall equipment effectiveness, or OEE, solution that is built around a scenario in a bakery. And then he's going to talk about the benefits and the journey that you can go on beyond that. And then I'll finish off with a little bit about how we can help moving forward. And we'll take some questions at the end. If you do have any questions whilst we're going through the content, please drop them into the chat function and we'll pick them up at the end. Okay, Andrew, next slide. Okay, so very quickly, CAD-IT, we are a global company. We've got a global presence, headquartered out of Singapore. The number on this slide in terms of employees is probably a little bit out of date. I think we're 700 plus now, not 600. But we've got, as I said, presence in offices across the globe, large presence in the Asia-Pac region, also in Europe, in Germany, in the UK, and also in North America as well. And we specialize in Industry 4 solutions. So we're a technology provider. We partner with other vendors, Siemens being our biggest one in this part of the world. And our areas of focus are on the next slide, Andrew, please. Sorry, I've jumped ahead one slide. So just to say that our solutions have been applied and we continue to apply them in many, many different sectors, as you can see on this slide, but we don't need to spend too much time on that. Thanks, Andy. Okay, so the last one from me, our solutions tend to fall into three camps. And obviously my world is the industrial Internet of Things, which is bottom right. And we pull together total end-to-end solutions that talk about connectivity to virtually anything. And the solution, be it on-premise or in the cloud, for visualization and dashboarding, etc., and analytics of that data that we might pull through the connectivity layer. But we also provide the consulting, the implementation services, and the training that goes along with that. And as I said, our solution in CAD-IT UK is focused around a product from Siemens called Insights Hub, formerly known as MindSphere. You can see on the rest of the slide that we've got many other solutions falling into service lifecycle management, which we deliver other webinars in, so look out for those if you're interested. And also we've got augmented reality solutions as well. Okay. So with that, I'll hand over to Andrew.
Okay, good morning, good afternoon, good evening, wherever you are in the world. So as you saw in the introduction at the beginning, my name's Andrew Howarth, and I'm the Senior Industrial IoT Consultant at CAD-IT. Now, I want to jump straight into a scenario here for a bakery. So this is the application of using Insights of OEE as a way to, what we say, really signpost some key issues that exist within any business when you connect assets, particularly within a manufacturing or production environment. So this scenario is based very much on a real scenario in industry where this particular bakery owner, known as Colin, has a challenge really where they need to be able to increase their production yield to meet increased demand and understand the effectiveness of his existing bakery assets on his production and really inform future capital investment. So if you've only got so much money to invest, where would you invest it? And wouldn't it be better to know which assets are performing worse than others, or that may need some maintenance, some investment to overhaul the asset, or do you actually need to buy new assets? What is the issue within your production environment? He is aware that there is significant waste from production already, but doesn't really have the data to back that up, all the insights to be able to make a sort of data-driven decision on where to make effective change. So what are the real causes of that? And then Colin has taken the option to invest in the insights of Industrial IoT as a service solution, and has chosen the OEE application to be able to benchmark and monitor the production assets that exist within the bakery and start to provide some data insights into where the issues lie within that bakery process. So you can see that process end to end here. And what we've really done here is picked out the key assets that actually exist across that bakery value stream. So there is a series of batch planning exercises that go on based upon recipes for different products that are baked. But the key areas of production are really centered around the ingredients that get weighed and then mixed at the mixing process. Those bulk mixers are then weighed again to make sure they meet the spec for the recipe. They're then baked in ovens. You can see that at various stages, the ingredients are coming out of dry storage or then being placed in cold storage to be reused later. And then finally, when a product has been baked and maybe decorated, it can then go through an automated packaging and finishing line, which will cut, package, and prepare the product for dispatch. Before the dispatch happens, there's a key check weighing for the product weight to make sure it meets the expected weight for those items in that particular product. Okay, so that's the context of the business. And what you'll see here within this demonstration is how connectivity of assets such as the mixers, the ovens, and the packaging lines can really gather up some insights so you can compare the effectiveness of those and actually drill down into a scenario where the OEE drops within the bakery and we see an outcome and an action taken based upon what actually caused that drop and how we can identify some issues. So what we'll take a look at next is the story that we're going to walk through here. So first of all, if you look on the left-hand side here, we've got the starting point here where the production manager is able to identify that there's actually a problem. Now, what I'll do in a moment is take you through the different options that are available to doing that, but the bakery owner or the production manager can either access dashboards or receive alerts to say that there's been a drop in a key performance indicator and a problem in the bakery. They can then quickly use the information that's available to identify where it is that problem exists, and then highlight a task for a production engineer to do some further investigation. So that production engineer can drill down into the information for the specific assets or part of the business where the issue has arisen from, and figure out what is it that's caused that problem, and then analyze that information to work out what they need to do to improve and take action and fix the issue. So two different personas and a number of different data sets that they can use to explore and investigate the problem. So I'm just going to jump out of this package now, and I'll take you into a live view of this particular demonstration. So you can see then there's a dashboard here that could be used, and it looks very different to the other dashboards that you see, but it can be used as a way of providing the operators, the business, the engineers, etc., with the specific information that they need to monitor what's happening within the bakery or within the facility. What this is here is a custom dashboard using no code, very drag and drop, that's available within the application. And we're taking the calculated data out of the OEE application that you'll see in a moment, and we're able to highlight that contextually alongside other data. So at the top here, you can see we're highlighting the net operational time, which is actually the operational time that's being used across the dispatch and final inspection area. So this is to highlight, is that part of the business actually able to dispatch enough products? You can see the delivery, and is the quality at the right rate? Then there's a breakdown of three key processes. So you can see the mixing area where there's two mixers, and you can see that it's currently running. There's a particular product, which is actually a flat pack, and there's 32 minutes of operational time over the last hour. Mixer 2 slightly more operational time. You can see the difference in availability. So clearly there's been some potential downtime there. And then you can see the products on Mixer 2. The same story for the ovens and the pack lines. So very quickly, this could be on a monitor within the facility. It's accessed via web application, anywhere within the facility or on the move. And we can see some quick key indicators of what's happening in production. Okay, so that's the overview dashboard. On top of that, it may be that you simply want to have a notification, not need to have a look at the dashboard. So in that case, if there is a drop in the productivity, you can see here I've received a notification to say that yes, there is a drop below a particular target, and that's indicated as an OEE error. So I've received an email, and this could be an email to the production manager to then be directed through the dashboard using the link that's been placed within that particular email. And that would take you to the dashboard that I was just showing earlier. Okay, so a number of ways of being able to visualize what's happening or being alerted to a problem within production. So now, once that alert has happened or the data, the KPI suggests the problem, we can take a deeper look using the OE application. So that's what you're now seeing on the screen. So here we're seeing the particular values for some data that's being pushed into the bakery today. So if I take, for example, from this morning, I'm going to look from 8 a.m. to around 10:41. So we're in that time. And we can now see what has actually been the performance at the bakery level so far this morning. Now, this particular values that's being presented at this sort of bakery hierarchy is a result of everything that's going out of the dispatch area. So there's not quite the performance expected, and there's a problem with quality. Now, if I look at the different products that are going through at this time, so there's CK1 and FL1, so this is cookies and flapjacks. I can see here that we're obviously the bakery is producing enough cookies. So the production manager can see that there's not an issue with cookies from performance. There is potentially an issue with quality. But then when we look at the flapjack, we can see whilst there's enough product going through at this rate, if we look through the whole day, we can see actually that the performance isn't meeting the expected rate and the quality isn't quite there as well. So clearly, at some point today, there's been an issue where the bakery is not being able to dispatch enough products, and particularly the flapjack product. So we need to take a deeper look at each of the assets. If we take a look at Mixer 1, again, you can see here the details of the mixer, and there's an OEE value there, which shows 30%. And the reason that OEE value is so low is because the performance, again, is not meeting the rate. So the performance is based upon the target rate for all the products or an individual product. In this case, Mixer 1 is only producing flapjacks. We can see over time, the change in performance. So it has gone up from a lower level. So clearly earlier in the day, there's a problem. And then there's further details around the operational time of this asset and then the machine status, which you can see at the bottom. So lots of information about the particular mixer. Now, if I quickly run through each of these, there's an easy way of comparing the performance of each one. So Mixer 2 is performing better than Mixer 1. The ovens, which are further down next in the process, are performing better, but you can clearly see that oven 1, which is part of the line 1 production line, is performing worse than oven 2. And then when we look at the packaging line, we can see again there's a performance issue and a quality issue. And then packaging line 2, this one is also running the cookies, whereas packaging line is producing the flapjacks. There's a problem with performance on packaging line 1 compared to packaging line 2. So clearly line 1 is having the biggest impact in the OEE within the bakery. So this is where the products for flapjacks are not necessarily being produced at the rate. And it seems there is maybe a performance issue. Now, if we just look back again at Mixer 1, you can see also there is definitely a lower availability on that asset than Mixer 2. So again, we need to investigate why is the rate not being met and why is the availability lower than expected. Again, if I look at this over the last 60 minutes, I can see that actually the availability is definitely much lower than expected this morning. So the production manager's thinking that there's a need to investigate the mixer here because the mixer will feed the oven and the packaging line 1. So it's very simple here to create a work order. So maybe an engineering department needs to be highlighted to this. So a work order can be assigned. We can just put a title or a description if need be. I'll assign this to myself. We'll put a due date on that. So the asset that it will be associated with is mixer 1, and this is an incident. I want a high priority on this, and you can see there's an option of what status this is. This is currently an open ticket. So now we've registered a ticket, so we can track the action that's going to have to take place here to investigate and fix this problem. So if I just go to the work orders, which will take me into a different application, you can see a list of historic work orders that have been assigned previously. I can simply look at what's been assigned to me or during the next 7 days. So this is the one that's just been raised. So now the engineer will have received this particular notification, and you can see there it's come as an email to me. So I can pick up this work order as the engineer, and I can go and have a look at the details of that work order, and then put some sentence in to say this is now actually in progress. Okay, so the engineer needs to carry out some investigation to find out what's happening here. So let's go back into the OE application. So the engineer now is looking at the data that the production manager has looked at and can see the same information around mixer 1. There's a problem around availability and performance. But there's more information available. So let's first take a look at what the actual availability is telling us. So you can clearly see here that over this period, there's been a series of unplanned downtimes indicated by the red, whereas the green is when the mixer was running. And you can see here some stats: 37 minutes of production time, 19 minutes of total planned downtime during this period. So there's been a problem, of course. From a performance perspective, we can see what the target is for this particular product, and that is the total grams that was expected to be weighed during this period. And you can see that actually the weight that's being weighed following the mixing is lower than expected. So the weight isn't meeting the expected target during the period, and the mixer is unavailable for 10 periods due to some unplanned downtime. We can look at the quality, that's fine. No problems with quality, but they're actually on the mixer, there's no real measure of quality. We'll see later on how the quality is measured as part of a later process. So let's take a look now at some downtime analysis. So this here shows us the number of occurrences of downtime that have happened on mixer 1. And you can see there's two different downtime times. So there's the motor and there's low oil, and it gives us an indication of how long it's spent in those particular downtime states. And you can see here from the timeline when that has happened. If we drill down through this, so we can see 10 minutes of total unplanned downtime. That's resulted to 21 minutes of stoppage, and actually it's predominantly related to the motor. A very simple, quick visualization, if you did have many different downtime events, to give the engineer a signpost to what they should be looking at as an explanation. So this can come directly from, in this case, the mixer's PLC. There's some status codes, there's some events, and this will send that information into the database, and we can analyze that information to understand how often the motor has caused a downtime event and for how long that's impacted production. So the engineer now needs to understand what's been happening when that particular fault occurred. So this here takes us directly into the time series data that's being captured from that particular motor. So I can have a look at what the actual voltage, vibration, and temperature is for the particular motor, because that's being captured. And what I'm going to do here now is drill into the analysis for this, and let's see what was actually happening. So you can see here now I've got a number of options to look at the data that's been selected for the motor. So for now, I'm going to switch off the status and the product information, and we're just going to look at the actual motor information. Now I can see there's changes in the motor, but I want to put some events on to see when there's been actual alerts. So I can see here there's been an alert where the OEE was below target. Okay, so I know that around this time is when there will have been some motor issues potentially. Okay. So I can drill down into this in various ways and have a look at different time frames, different analysis. I can put some annotations on here if I want to highlight something that I've spotted. And I can look in to see what is actually happening on the mixer during the times when the motor is running. So I can see here the period when there was actually no order ID being produced from that mixer. Okay. So what I'm going to actually do then is look a little further at the other parts of the operation to understand what was coming off the mixer. So the mixer has, after the mixing stage, there is a weighing stage. So this now gives me the information related to the weights that are coming off that particular mixer. So again, if I take some analysis and I switch on the events that were triggered, I'm now starting to see there are a number of low bulk weights. So there's been a problem with the motor speed. There's been a drop in the OEE, and the measure of the product that's coming off that mixer has indicated that a lot of the time the weight isn't quite meeting the specification, which could be a result of the motor speed. It could be a result of the mixing. Okay, so the engineer now has a lot of information related to incidents that have occurred due to the weights being too low and the motor speed changing on that particular motor, and knows that this is relating to the issues on mixer 1. So now there's a number of improvement actions that the engineer can take and advise on. So if we go back into the OE application, we can actually look at assigning a measure to this downtime analysis. So in the downtime management, we can see here, the most significant motor failure. It may be they want to make a repair to the motor, which might be to replace some bushers. It may be to replace the motor. So we could assign a replacement of the motor. It could be that it gets assigned to another engineer to do, and further comments can be added to that. But this now gives some information back into the database to say this was the fix that was applied to this particular incident, which will build up as a series of common fixes over time that could be used for further analysis. So the engineers determined that the motor needs to be replaced. But what about the issues further downstream with quality? If we take a look at the packaging lines, we noticed earlier that actually the packaging lines had a difference in quality that was being measured from the result of those packaging lines. Now, in this particular baker scenario, the weight coming off the mixer, the bulk weights, will impact the weights that are able to be achieved when the packaging's occurred and the items are actually produced. I'm just going to do a refresh here because we've got a bit of a slow connection over the Zoom. So here you can see packaging line 1 and packaging line 2. So packaging line 1, if we look at the quality, we can see there's been a lot of items during the period this morning that incident occurred, which on line 1 is likely to be a result of the weight issues that were detected from mixer 1, therefore resulting in low weights maybe, or products that didn't meet the spec once they were packaged. So they've been allowed to go through the process, and it could be a combination of products that just didn't meet the weight, or products that didn't meet the weight because of mixing speed issues. But you can see how a lot of this information can come together to highlight what the problems are and do the right investigation. So it may be that actually in future we need better detection of this. We need to be alerted to when a motor failures rather than waiting for all these errors to occur. So there's an opportunity here to set up a rule on any asset for any data. So you can see there's a number of rules here, but what we're going to do is actually go to the mixer. We're going to set up a rule, and you can now see how easy it is for the engineer to set up a rule, maybe for the vibration on the motor, or the temperature on the motor, or both. So you can see here, we can select the asset, and we can say that if this is greater than a particular value, so maybe 40, and then if this is greater than 30, for example, it will highlight on the asset, if I select this, that there's a problem by going red, and I will receive an email tell me that there is a problem. If you do have an additional application called the thematic notifier, this can also come as a push notification to your mobile phone as well. So I want to make this an error. And you can see I've given that a description. Give it a general name for the rule. And now I've got an active rule, which when this incident occurs again, I'll receive a notification to indicate that actually there's a problem on the motor, and maybe we can avoid running the mixer and therefore running products through the production value stream that could end up being waste once they go through the packaging line. So there's really two elements to this that have come to play here. We've got OEE, which is signposting there's a problem. We've got drill down into that problem, which can highlight that there's a particular asset that's at fault. The engineers got the data to analyze that asset and see values on the mixer, see incidents that have occurred on that mixing process, and they make a determination by centering in on the motor of what to do next, and then highlight the action that's been taken. From that action within the digital tool, there's also the ability to very quickly set up or update notifications, so you get much quicker detection of faults within the process. Now, this is very much using, in some ways, AI in sort of a sort of human-centered form. If we took this a step further, so if we go back to our slides, we could start to look at, well, what benefits were I getting, and what else could I do? What else could I do next to improve even further? So typically with this scenario, you can see increases in productivity, such as 20%, just through being able to have access to this data or get early notifications and detections, just as you've seen. This will result in a reduction in unplanned downtime because of this faster reaction. But also by having the information across all the assets, you're getting a baseline about all your machine's performance, which helps when you're comparing them in real time in production. But it also helps when you are actually looking to invest in new assets. You know, which are the assets which are commonly causing problems? How often are you getting regular motor faults or low oil errors? And you can compare that across assets and see which ones need more attention. And as you saw, a reduction in waste by avoiding over or under mixing can be a key outcome of making those adjustments and taking action. I just wanted to highlight where this customer in particular is on this typical journey, because what you've really seen here as a story is very much an entry point, an early part of taking advantage of connecting some assets using Industrial IoT. So you can see here the time to do this is much lower than if you jump straight in with trying to maybe use some machine learning models to create some predictions. So very quickly, if you're not already doing that, you can use OEE and condition monitoring, just as I've shown, to detect issues, resolve problems, and get some benefit from that investment. But as I mentioned earlier, what else could you do? There's further steps and further opportunities within IoT and with the data that you've started to collect and store for your particular assets and business. In this case, in the bakery, the mixers, the ovens, the weighing lines, etc. We could actually start to look at the energy they're consuming, but use the data that's being captured for that to predict what the energy consumption might be, and then business could take some actions to try and reduce their energy use, which would reduce cost and, of course, carbon footprint. But furthermore, with a little more time, the data could be used to create some machine learning models. So the data that you're getting about the product, about the weights, the process values when that product was produced, the mixing speeds, the temperatures, etc. Rather than setting alerts to wait until problems occur, you can actually allow for machine learning models to create anomaly detections and predictions of a failure on a process before it actually happens. And that's using all of that data to create relationships between them and select a target for potentially failure of a machine or a product, and see if it gives you a prediction or an alert to tell you that actually this process is likely to fail before it actually fails. But you can see here on this very simple timeline, it actually takes more effort and a little longer to do that than it would do if you just started here on the left-hand side with OEE and condition monitoring. So it is a journey, very much a journey that you need to go on. Okay, so that concludes the story of the bakery, and it is a real journey that one of our customers is on, and obviously an example demonstration of how the data can be used to analyze a problem. I'll now hand over to Gavin, who'll just explain how we can potentially help you and what we can offer you if you're looking to do something similar within your business.
Thanks, Andy. Thanks. So something I should have said at the beginning really is, I know we've focused on a bakery scenario here, which is food and beverage aligned in terms of industry sector, but this really applies across manufacturing, whether you're making aerospace, automotive, heavy machinery components, whatever it might be. This applies. It doesn't matter whether you're mixing and baking and packaging, or 5-axis machining, processing, heat treatment, and things like that. It's exactly the same approach, exactly the same application of the technology. So with that, what we will do is as a thank you for taking time to come and listen today, we will offer a free one-day consultancy on application of industrial IoT in your business. Along that, we'll do some deeper demos with different use cases as well. And we can do that either remotely over a Teams call, or we can do it face-to-face at your premises if that's what you would prefer. So I'll reach out to everybody that's joined the webinar today, and you're all entitled to that as a thank you for coming and listening to us. And with that just leaves us to look at questions. And I can see a couple in the chat now, which is great. So thank you for those. We'll take the first one. And Andrew, this is probably best for you to answer. So the question is there an option for the operations to manually select or input reasons for lower performance as it happens?
Yes, thanks, Gavin, and thanks, Martin, for the question. The answer quite simply is yes. Let me just quickly show you that if I can, because that's probably the best way to give you an actual example that's available. So as this is a cloud-based platform, it's Siemens Industrial IoT. You'll probably be aware that means that it's evergreen and it's always being updated. Sorry, bear with me a moment. I'm struggling to get this to go to full screen. But as a result, there's a number of improvements constantly being added to this over a period of months. But if we look into the application, there's a number of apps you can see here. So this is the OEE app. But to your question about the downtime, so if I go to, for example, the mixer that you saw earlier, and I select the downtime management, there is a reason tree being built in the background that you control. Now, whenever there is a fault, you can see here, unplanned downtime, stop motor, this can be changed. Okay, so if we felt that this was the wrong reason that was automatically created, then that can be changed based upon a predefined reason tree. Now, these reason trees are created in a very simple configuration flow. So you can see here, here's the reason tree. You configure it manually if you want like this. So here's your time category. So different states of time and different states that the machine is related to that category. And then your reason layers. And all of these reason layers can relate to a value that's coming from machine or something that you calculate using some data transformation. And that happens with status mappings. So you can see here, I've only got a few of these mapped. So if I see a value of 1, it means it's running in production. If I see a value of 4, it's got low oil. But one of the beauties of this is that rather than necessarily having to build all these manually, you could import these. If you've got a very large reason tree, lots of different states, put them all in a simple CSV file in Excel and then import them in, and you can manage that reason tree then and update it at your leisure. And as I showed, it gives the operator or the team or the engineer, we've seen this in scenarios where at the end of a shift, the team may review all the downtime reasons that have occurred and be able to discuss with the team whether it's the right reason, or do we need to update them and change them, or even remove them if we think it's affecting the results. But you get full control over that. And as you saw earlier, you can assign measures. You can then assign work orders for ones that you want to pass on to the maintenance team, and put some comments in there if you've got some production context that you can add. Okay. When I mentioned there's some updates happening all the time, one of the things that I know is coming in here is the ability to also add your own product info and quality information into the tool manually, rather than it coming from somewhere else. Currently, what we tend to do is use another simple dashboarding tool to provide a user interface to operatives or planners or production managers to input information. And then that simply just pulls into this application. But there will also be a user interface in here where you can enter that information directly. If you're not automatically getting things like the order or the product, all that information can come in. Okay, hope that answers the question.
Okay, and we've got one last question. I'm just conscious that we've gone over time slightly, but it's a really good question from our friend David Prosser. What do you think are the primary barriers, to adopting IoT solutions? Well, that is a great question, and it's a topic that you could discuss for hours and hours. For me, I think there's two aspects to it. The first one, and the most important one, and probably the most difficult one to crack, is culture and people. I just think as a manufacturing workforce, we have got a long way to go in terms of readiness to adopt this quickly. Obviously, we've seen, the younger generation coming through are more adept to this type of technology and consuming it as part of their normal daily and working lives. But we've got a huge population of people that aren't ready for it yet, and we need to think about that when we're implementing the technology. And the other aspect of it is the physical aspect of our manufacturing estate. Very, very brownfield. We've got factories with aging infrastructure. I know people are investing a lot, and it's great. But people are still sweating assets out there that probably unconnectable in their current state, but they're still creating value for businesses. So we've got to make a really compelling case for people to invest and upgrade assets as well as the underlying infrastructure as well. Anything
Yeah,
for you, Tyler?
sorry, Gavin, go on.
No, I was just asking if you've got anything else.
Oh yeah, I was just going to add to that. So obviously the point around people and culture is a really important one, and we always see it as probably the most important area to focus within a business, particularly up front when we're looking at trying to help a business get value from their investment. So there's a lot of this effort in understanding who the end users are, the personas, and then how we can help with training and communication, and that ongoing support to make sure that really people understand why the application matters, how it can help the business, and what their role is in using the tool set. From a technology point of view, things have moved on and changed over a number of years now. So the ability to quickly connect assets has really sort of accelerated, and that's great, because the effort level to start surfacing that data to feed these applications sort of decreased significantly. Are there still brownfield assets out there, as Gavin mentioned? Yes, of course, and there are still some that are really difficult to connect, but the number are getting fewer and fewer because of technology that you can use to either retrofit onto assets such as sensors, or just the fact that the asset may have been procured within the last 10-15 years, in which case it's already got the inherent technology to be able to be connected. So the connectivity's got much easier. Yes, there's still challenges, and that needs to be explored, but really the people and culture sides are a really important one to focus on, which we put a lot of effort into here at CAD-IT.
Okay. So then no more questions, but that's fine. We have gone over time, which I apologise for. Thank you again for sticking with it. Thank you for listening to us. I hope you enjoyed it. I hope you got something out of it, and I will reach out to you all very soon.